Okay, we want to address the topic of solving equations, which is a big deal. Okay. I'm not going to talk much about solving linear equations because everybody is pretty good with linear equations, except the ones where x is in the denominator. Okay, so we'll talk about those. But we have linear equations. We have quadratic equations. And there are polynomial equations. Mostly where we try to find the zeros of a polynomial, okay? Set a polynomial equal to 0, so if we can factor it, we can easily get the zeros. Exponential equations. And logarithmic equations. And now, solve an exponential equation, you're going to change it to a logarithmic equation. Solve a logarithmic equation, you're going to put it in the form of an exponential equation. If possible, some equations are just complicated and you can't do any of that. But you're not going to see any of those. Okay. We have matrix equations and simultaneous linear equations. Fair enough? Anybody think of any other kind of equation we've encountered in this course? Do you want me to think of another type of equation? No, you don't. Okay, well, that pretty well covers it. Okay, so I'm just going to illustrate the basic ideas and some of the operations without going through all the detail in solving every equation. Now, for linear equations, I'm only going to look at one kind of equation, which is like, let's say 5 over x plus 7 equals 3/8. This is something that I have trouble convincing people to do. And what I'm talking about is multiply both sides by common denominator. Okay, denominators. Are x and 8. So I say that the LCD, the least common denominator, is 8x. So we multiply 8x. And you can put the 8x over 1 if you want. Now I'm just going to do it. 8x times 5 over x. Base 8x plus 8x times 7 equals, I'll just leave this one with simplification of the next step. Okay, now I've got an x in the numerator and x in the denominator. So they divide out and I end up with 40 here. And 8x times 7 is 56x. And we have an 8 in the denominator and 8 in the numerator. And that leaves us with just 3x. And now the equation is very, very easy to solve, and I'm not going to take time to do it. Okay. You want to write down the solution, it's going to be x equals 40 over 50, negative 40 over 53, I think. Question mark, check and make sure I'm right. Okay. Now, solve quadratic equations. First, you got to recognize it as quadratic. Let's take the equation I wrote here. But let's write it. Let's just change the denominator of the term on the right from 8 to x minus 8. Well, now the common denominator is x times x minus 8. So we write x times x minus 8 times 5 over x plus 7 equals x times x minus 8 times 3 over x minus 8. So what do we have? And make sure you multiply the whole side by the x times x minus 8. And this gives us x times x minus 8 times 5 over x plus x times x minus 8 times 7 equals x times x minus 8 times 3 over x minus 8. Well, this x will divide this x, leaving us x minus 8 times 5. X times x minus 8 is x squared minus 8x. This is going to end up giving us 7x squared minus 56x. On this side, the x minus 8's divide out, and we end up with 3x. Notice we got this x squared here. Okay. We say, aha. This thing is quadratic. We can recognize it. When we multiply everything out, we'll have x squareds and x's and just plain old numbers. Okay, well, we continue then. But what we're going to do is we're going to put this into the form equals 0. So we can use the quadratic formula because we have very little hope that we're going to be able to factor this thing. Now, on a test, maybe you'd have hope that it'll be factorable, but I didn't make it up to be factorable, so it's unlikely that it will be. Okay, so multiply this out, we get 5x minus 40 plus 7x squared minus 56x. And I'll just subtract the 3x from both sides in my head. And you're going to get 0 over here, and you're going to get a negative 3x here. So now we can write this as 7x squared minus 54x minus 40 equals 0. Now, what I've illustrated here is an equation of the form that would you'd be most unlikely to recognize as quadratic. You don't even see an x squared until you multiply through by the common denominator. Now, if you really want to punish yourself, you can put everything in here over common denominator, do the addition and all that stuff. Okay? But that would really be a pain. You have this form, you want to clear the denominators. You don't want any denominators left in your equation. So you multiply by the common denominator, just like you do here. You don't want to deal with those fractions. Okay? Clear the denominators. Something I have trouble convincing people to do. And something that you really should have done a lot of in an algebra 2 class. Okay. So now how do we solve this? Solve it using the quadratic formula. You'll get a positive discriminant because your minus 4ac will have a positive value of a and a negative value of c. So minus 4ac is going to be positive. Squaring your b term is going to be positive. And we're not going to do the numbers in. Okay. Now, if you think you can factor that, yeah, go right ahead. Maybe you can. I kind of doubt it. So does that make sense? Another form a quadratic equation could occur in is like three times the quantity x minus 5 squared equals 12. Now you can expand that square, you get 3 times the quantity x squared minus 10x plus 25 equals 12. And bring everything over onto the left side and use the quadratic formula if necessary. Okay. That would be more trouble than you need to go to, because all you have to do here is say, okay, well, then we divide both sides by 3. And you get x minus 5 squared equals 4. Now, a lot of times, I'll do the square root of both sides, but common sense is if x minus 5 squared equals 4, then x minus 5 has to equal whatever you square to get 4, which is going to be 2. Okay, but we'll do the operation. We'll do square root here equals square root here, except when you do square root of both sides, it's really going to be plus or minus square root, because there are two numbers that you can square to get whatever number you're looking for. Okay, well, this gives us x minus 5 equals plus or minus 2. You have to include minus 2, because if you square minus 2, you are going to get x minus 5. Okay. Yeah, sorry, if you square minus 2, you are going to get 4. Okay. So x minus 5 equals 2, or x minus 5 equals negative 2. So that x equals 7, or x equals negative, x equals 3. And you can check that. is 3 times 7 minus 5 equal squared equal 12. Yeah. 3 times 2 squared equals 12. 3 times 4 equals 12. 12 equals 12. You can check that box. And similarly, 3 times 2 minus 5 squared equals 12. I'll put yes in parentheses down here. You can plug that in and see what it works. Okay. And that's pretty much what you need to know about quadratic equations. Except, of course, this is a quadratic equation because if you multiply these out, you're going to get a 6x squared. You want negative 15x and 18x plus a 3x then, and minus 45. Okay. You've already got it in a form that makes it easy to solve. Solution is 2x minus 5 equals 0, or 3x plus 9 equals 0. And I'll just put the center. You can solve this, you're going to get x equals 2.5. Solve this, you're going to get x equals negative 3. Plug negative 3 in here, you're going to get a 0 for this term, and so forth. Okay. I've urged you all along to write out logic, write out the ors or the ands. Okay. But that kind of covers what you need to know, or at least reviews what you need to know to solve quadratic equations. Okay, so polynomial equations, I said factor the thing, then use a zero product of multiplication, property of multiplication. For example, if you factor the polynomial, what would the degree of this polynomial have been? It would be degree 4, right? Because you have an x that can multiply an x that can multiply an x squared, giving you an x to the 4th term. Okay, if the polynomial factors like this, then okay, this or this or this. Read that. So this gives you x equals negative 2. This gives you x equals 2. And this gives you, well, we could do, this gives you x equals the square root of 6 odd. So now if you want to graph this polynomial, how do we graph polynomials? We graph their zeros. Okay, so x equals negative 2. I'll just read this. X equals negative 2 on this line, there's a 0. X equals 2 on this line, there's a 0. We have a y-intercept. We just let x equals 0, and we get 6, negative 24, and 140, negative 144. Y equals negative 144. Long-term behavior. long term is like x to the fourth. And x to the fourth has a graph. It looks a lot like a parabola, but it's pretty flat. So we know that it goes up here and it goes up here. The long run behavior is going to be up on both sides. So what's the graph going to look like? Well, it's going to be a pretty simple looking graph. It's going to come down from up here through this point. It's going to come down here, probably flatten out quite a bit, and then going up like this. Probably be flatter down here than I drew it. Okay, now remember, we talked about you take the highest degree, you look at the shape of the highest degree. If you have even degree, it's going to look like this. Less flat if it's a degree 2, more flat if it's of higher degrees. The higher the degree, the flatter this thing gets, and the steeper it gets in the sides. So where it approaches something that kind of makes a right angle down here and a right angle here. It never really happens. But it gets very flat. Okay. Still, you got wiggles in the long-term behavior, and this doesn't really look like wiggles, but it's really got kind of a wiggle. There's probably a wiggle associated with this, but you don't know how to analyze that. Okay. And you'll learn how to analyze polynomial functions in calculus if you take calculus. It's pretty easy, but can't talk about it now. Okay. As mentioned, if you have even degree, then the long term is like this. Odd degree, the long term. Be like this. Now, when I say it's like this, it could be upside down. Okay. If I'd have put a negative sign in front of this, I'd have still had the same zeros, but my y-intercept would have had to be positive. It would have ended up being positive. So, you know, flip this shape upside down. You can flip this shape upside down. Okay. Or reflect it vertically. It amounts to the same thing. Reflected through the origin. Okay. So you want to be able to graph polynomial functions, and really with practice, it should be pretty easy. If you have the factored form. If you don't have the factored form, well, I might ask you to do that. Okay. If you don't have the factored form, how do you factor this? Well, let's put it in the form of an equation. Okay. I lied, but not, I'm telling the truth. X equals -1 is a solution. Okay. If you plug -1 in, -1 cubed is -1. This negative makes it a +1. This x is a -1. So this x cubed. But if you plug in -1, this and this give you 0. Also this and this give you 0. Remember that when I say by inspection, I mean like all I really expect you to do is try numbers like 1, 2, maybe 3. Or -1, -2, or -3. See if they give you 0. See if one of them gives you 0. If not, give up. Okay. You could try the rational zeros and stuff like that. But if I give you one that you can factor in this way, it's going to have integer. It's going to be a small integer, no bigger than 3 or less than -3. Okay. Okay, so anyhow, there it is. How do you now factor it? You do x minus -1 divided into -x cubed plus 6x squared plus x minus 6. Well, x minus -1 is x plus 1. And you divide that in here, you're going to get a -x squared, which will give you a -x cubed plus, or sorry, minus 6x squared. Okay. When you subtract these, you're going to get 0 here. And then you got the x, uh-oh, something's wrong. I'm sorry, it doesn't give you 0. You got a -x squared here, 6x. You get 12x squared. I just made the common mistake of not putting a little plus sign here and a little plus sign here to show what I'm really doing when I subtract these things. Okay. Now I expect that you know what I'm talking about. If it's not totally familiar to you, there's a red flag, review it. People did pretty well with this when we did it. Just a long division thing. Okay, anyway, then you're going to get plus 12x. And it's still not working out. What's wrong? Am I doing something ignorant here? Kind of obvious that must be. That's going to be a minus, that's going to be a minus, that gives me a minus 11x. But arithmetic must be off. I don't see where that has occurred. 6x squared is going to give you 6, minus 6 is going to give you 0. X cubed and x will have the same sign. But the -x cubed makes that 0. So apparently, oh man. Okay, give me a second. I wrote down a 6x squared. There's no 6x squared there. I was writing down what I saw rather than what I get because I was moving too fast. Okay, let's do it again. Okay, -x squared times x is -x cubed. -x squared times 1 is -x squared. If that's going to be a plus, that's going to give me 7x squared plus x. So that's going to give me a plus 7x. And then I come down here, I get 7x squared plus 7x. I'm really subtracting here and subtracting here gives me -6x minus 6. And then I get minus 6 here. And that gives me -6x minus 6. Everything subtracts off. Okay. This is the process. Be more careful than I was. Write things down systematically and carefully. Then we know okay. It's unlikely anything I make up randomly would factor, but the way this is structured, it is structured in such a way that it needs to factor. I'm going to bring this negative sign out here. We get x squared minus 7x plus 6. In other words, I multiply this by -1 and put my negative sign out. I multiply the whole thing by -1. Okay, and we get negative of x. And now negative doesn't matter because it's equal to 0. We get x plus 6, x minus 6, so that's x minus 1. Okay. Right, just a little slower, so I have time to do correct. I'm sorry. X plus 1 times x minus 6 times x minus 1 equals 0. And now we just break it into 3 equations. And we get x equals -1, x equals 6, x equals 1. So now if we want to graph it, we have a 0 at x equals -1. We have a 0 at x equals 6. We have a 0 at x equals 1. And the y-intercept, if x equals 0, well, you can see that we're going to get -6 using the original form. The graph is cubic. This should have been an x cubed. The graph is, the function is cubic. So it's going to have this ultimate form or a reflection, which would be like this. In order to go through these points, it has to be like this. Go that, up here, and go down here. So overall, it looks like this. You got these little wiggles in here in the middle. And that's what the wiggles look like. The rest of it looks like it's just shooting up faster and faster, shooting down faster and faster. And I think a lot of what I wrote here isn't on the screen. So let me just quickly. After doing the long division, I know that this thing equals this times this. There it is. Okay. Now I find that this can be factored. It's easier to factor if I use x squared minus 7x plus 6, which I can do just by multiplying through by -1. Okay, it gives me this. Still equal to 0, so that I can again multiply by -1 again and get all this. Okay, it gives me this. Everything factors. So now I get my 3 zeros. I mark those on the graph. I'll mark my y-intercept. And this is just a process we always use once we have a polynomial factor. Okay. You want to review what we did with rational functions. I'll probably add another short video at some point, but I'm not going to go over that right now. If I have time at the end, maybe I will. Okay. But for rational functions, you look at zeros as the numerator, which give you x-intercepts. You look at zeros as the denominator, which give you vertical asymptotes. Unless some of the zeros of the denominator match zeros of the numerator, in which case you have removable singularities. Okay. Okay, now I'm realizing that Zoom isn't going to finish because I didn't close Zoom. Okay, we've talked about linear equations, quadratic equations, polynomial equations. Exponential equations and logarithmic equations are easy unless they're impossible. And I'm not going to give you any impossible ones, at least not intentionally. Okay. Examples. Four times 3 to the x minus 6 equals 18. Well, we can divide both sides by 4 and you get 3 to the x minus 6 equals 18 over 4, which of course is is 9/2. And now we change this to logarithmic form. We get log base 3 of 9/2 equals x minus 6. So that x equals 6 plus log base 3 of 9/2. That's your solution. Now that requires that you understand how to change between logarithmic and exponential behavior, or vice versa in this case. Remember that log base b of a, sorry, that this b to the a equals c is equivalent to log base b of c equals a. And that's what we used here. B was 3, a was the x minus 6, and c was 9/2. It's converting to log. It's going to be then the log of c, which is log of 9/2, equals a. A is x minus 6. There we have it. Now you can also write this as log of 9/2 over the log of 3. Use your calculator to evaluate these. Calculator you'll have available in the testing center, I don't believe does a log to the base b. A lot of calculators, online calculators and so forth do. So make sure you understand this rule so you can simplify this. And that's probably going to be about maybe, oh, that's 4.5, so it'd be about 6.3, maybe 6.4. But plug it into your calculator. I did that quickly. I don't trust my little calculator. Logarithmic equation, like I'll use a natural log for an example. Natural log of natural log of x minus 8 plus the natural log of x plus 2 equals 12. What do you do with this? Well, you use the rules of logarithms. And you get natural log of x minus 8 to the 5th plus the natural log of x plus 2 equals 12. But then, of course, you can combine these and you get the natural log of x minus 8 by 5 times x plus 2 equals 12. And natural log is log base e. So we get converting from log to exponential form. We get e to the 12th equals x minus 8 to the 5th times x plus 2. E to the 12th is just a number. Okay. Now this is a 6th degree polynomial, and you're not going to be able to solve this. And I'm demonstrating that you can combine these things. And if this is just x minus 8 and x plus 2, this would have come out a quadratic. Okay. And you would have been able to solve it. Let me illustrate that. I wanted to illustrate the rules that you can use to combine logs. You can get an equation. It's just an equation that you're going to have trouble solving. And I'm not going to ask you to solve one like that. I might ask you to simplify an expression like this in a separate problem, but probably not in an equation that you're going to solve. Okay. If the equation was just natural log of x minus 8 plus the natural log of x plus 2 equals 12, you'd have natural log of x minus 8 times x plus 2 equals 12. So that you would have e to the 12th equals x minus 8 times x plus 2. That would give you x squared minus 6x minus 16 minus e to the 12th equals 0. Now, e to the 12th is just a number. I don't even want to hazard a guess at what e to the 12th would be, but I think maybe it would be something like 16, 16, 17, 18,000, something like that. Okay. Punch it into your calculator and see if I did that right. I don't think I did. Third power, 12th power. E to the thirds, a little more than 16. E to the 6 would be 256. Square that. And you get something like 4,000, 5,000. Okay, get around it. Let's not worry about that. You're going to get a big number here, but you would be able to plug this into the quadratic formula and get a solution. You'd have to approximate it. But you can approximate e to the 12th as closely as you like. Okay, so you might see something like that. That probably wouldn't throw an e to the 12th out. You'd probably use a log base 2 or something like that. And the numbers are easy. And you get exact numbers. Okay. Anyhow, that's exponential logarithmic equations. A matrix equation. Simultaneous equations. And I'm going to get rid of this. You got to know this. That's the key to solving logarithmic and exponential equations. It's the inverse function property. Okay, let's take a matrix equation like 2, 3, -5, 1. That's an equation. You could be asked to solve that equation. Okay. What you would do is you just convert this to two simultaneous equations. You multiply 2, 3 by x, y. You get 2x plus 3y. If you remember how to multiply rows by columns, and everybody was doing really well with this as late as last week, so I think you do. Okay, but just to refresh you, you multiply the row by the column, multiply this row by this column, you get negative 5x plus 1. That equals, well, negative 4. So 2x plus 3y has to equal 12. Negative 5x plus, I had plus 1 plus y. 5x plus y equals negative 4. And you got a friendly system of simultaneous equations that you can solve by elimination, or you can solve with an augmented matrix. Okay. This gives you the augmented matrix 2, 3, 12, negative 5, 1, 4. You start by taking half of the first row, you're going to get 1, 3 halves, 6. You have negative 5, 1, 4. Then you do 5 times the first row added to the second. And you're going to get 1, 3 halves, 6. You're going to get 0. And 5 times that's 15 halves, 17 halves. And 34, I think. Okay, so I'm not going to continue with this process, but this is a process everybody was really good at when we did it. So just make sure you're still really good at it. Okay. And that kind of reviews a lot of what we do with matrices, and also kicks you off to solving simultaneous equations by elimination. Stuff we've done very recently, so I'm not going to spend a lot of time reviewing it. Matter of fact, I'm done. Okay. So that's matrix equations, simultaneous linear equations. I don't know if anybody's looked, but I posted at your website, at your assignments page, document, I think. And I'll double check this afternoon when I post these to make sure I really did. Post the document that kind of gives you a pretty good idea what's going to be on the test, the exam. Okay. There is a problem bank that I've developed for the what's going to be the departmental final exam. It's a part of the final exam that everybody's going to administer in this course. Our adjuncts, those are teaching in the dual enrollment, those that are teaching on campus, and full-time faculty. Okay, we're all going to do this in the spring. I've developed it, but with feedback from everybody else. I said, hey, Bonehead, would you do that for it? I fixed it, you know, stuff like that. And at least I hope they'll say that at some point. I haven't gotten a lot of feedback on it actually. So I'm going to administer the thing. Okay. It's going to be 5 problems. Everybody's going to have the same 5 problems, but there are going to be 5 more problems that are all going to be different. Okay. The 5 problems that are the same for everybody are going to get graded. 5 problems that are different are going to be used to assess the performance of the class. It's an objective assessment of how the class as a whole is doing. Okay. And then what we do is we compare that assessment with the grading pattern. So we can say, yeah, just everybody's giving B's for 60% of these random problems. Okay. Except one guy who's giving everybody A's no matter what they do. Okay, or except one guy who's given D's for that, right? We want the grading patterns to be consistent, and that's the whole purpose of that thing. Now, the point for you is you're going to have 10 randomly generated problems. And I've given you samples of every type of problem that could be. There are about 80 of them. I don't expect you to work them all. Most of them you can look at and say, yeah, I know how to do that. Or no, you know, I'll drop out and go live off the grid before I do that. Okay. Seriously, you can look through the ones that are kind of in between and review what you need in order to be able to do those. There are 80 of them, roughly, give or take. I haven't counted them. Okay. And that's going to be half your test grade, half your exam grade. Now, the exam grade again is going to be on the 5 that I've chosen to put on the exam. Okay. And they're totally valid problems. They're right along the lines of everything we've done. Might be stated a little differently, so do look at that document. Then you're going to have the other half of the test is going to be, you know, stuff I put in the video Tuesday. Okay, video's already posted. It's basically, okay, construct this toolkit shape, right? Then move the red dot here. Now tell me what the equation of the function is. Estimate some points on the graph and verify that when you evaluate the function, you get those points. It's the same thing you had in the midterm. Okay, it's gonna be like 20 points out of 100. Okay, the 5 problems that I talked about are going to be 10 points apiece. That's 70 points. I'm trying to remember exactly what I did with the rest of it, but I'm going to just rely on you to read it. You'll recognize what it is. You'll know, and it's going to be predictable for the most part. Okay. It's going to be stuff that you just really need to know how to do. Okay, make sense? So that 50 points, if you prepare properly, you should get those. Okay, so make sure you do. And then make sure you prepare everything else and stuff I'm going to do. Okay. Then I think you're going to do okay. Because what I've seen from you, everybody seems to be doing okay at this point up through the midterm. Okay. Yeah, some people making a higher score, some people low, but everybody so far has been in the passing range. Okay. But more passing, you know, to see a better range. But don't let that drop because the final comes very heavily. So make sure you're prepared. Okay, well, let's talk about what I did in the previous class. Okay, in the support class, I did more reviews since we didn't have the review on Tuesday. And I reviewed something that everybody in a support class would need, whether they're in my section or not. So I did stuff that's semi-unique to this section. We have 2 points. Okay, we have the point 2, 4 and the point 8, 9. Now at the beginning, we just have those 2 points, nothing else. So try to imagine that. But what we want is we want to get an exponential function through those 2 points. We want to get the exponential function. Well, exponential function has this standard form. There are other standard forms like a e to the kx and stuff like that. And you might see that on the file. I've stuck pretty much a b to the x here, but you have a e to the kx forms in your homework. So make sure you kind of review that if you we're not familiar with it. A linear function through 2 points. Well, that's either y equals mx plus b, or like x minus a plus y, x over a plus y over b equals 1, where a and b are the x and y intercepts. Okay. And we'll use this form. Haven't talked much about that form, but it is another form you could use if you really want to. If you want to show off and you're done with everything else, go ahead and see if you can do it with that form. Okay. Oh, another thing on the final, I'm jumping around here, I'm sorry. You're probably going to put some optional problems at the end, okay? And, there are problems that if you can do them, I'll average them in if they help you grade, okay? So that allows me to ask a few more creative things that you might not be able to do, okay? Okay, anyhow, okay, again, through these 2 points, we can put a linear function just like this. Put an exponential function. Start over here and curve up through here and go up. Okay. So you can see that an exponential function could fit these 2 points. Or a quadratic function with a vertex here. Well, vertex would be here, so the axis of symmetry would be here. So the curve would look something like this, wouldn't it? Or the vertex could be here. So the axis of symmetry is here. So the graph would be like this. That makes sense? Okay. Well, we can do that if we use the form, vertex form y equals a times x minus h squared plus k. With 2 points, we can't do this. Why not? Because there's an a, a b, and a c. We've only got 2 points. If we substitute the coordinates x and y of the 2 points, we get an equation in a, b, and c. Okay. If we use this point, we get another equation. That's 2 equations. We still have 3 unknowns, a, b, and c, so we can't solve it. With the vertex form, we can, because I've told you that one of these points is the vertex. It gives you a lot more information than just 2 random points. Okay. Now, if we had 3 random points, we could plug the things in and get 3 equations and 3 unknowns. I might actually ask you to get those equations. I probably won't ask you to solve them. Okay, but it could happen. Using the vertex form, knowing that one of these points is a vertex, then we know what h and k are. And we have another point, so we know what its x and y is. So all that's left is a, and that gets really easy. Okay. So anyhow, what we did, and this is on the video there, so I'm going to go through it real quickly. But a linear function through 2, 4, and 8, 9. We use the form y equals mx plus b, plugging in 2 for y, 4 for x, 2 for x, 4 for y gives us this equation. Plugging 8 for x, 9 for y gives us this equation. We write the equations like this, and we solve them. I solve them by elimination. They could be solved by substitution. Okay. Now that should be a real familiar process because we've done it very recently. But that's how it applies to get the equation of a straight line through 2 points. And then we check the point, we plug the coordinates of the points in and make sure they fit and so forth, okay? Now, sticking with these same 2 points, we get the as soon as I find it. Oh, yeah, here it is. Okay, we get the quadratic function of the vertex of 2, 4, passing through 8, 9. Now I ask people to vote if they want to use the point on the left or the point on the right for the vertex, okay? Everybody chose the point on the left. Then we went ahead and did the point on the right too. But choosing the point on the left, we'd be finding quadratic function of the vertex of 2, 4, that's here, through the point 8, 9, that's here. This turns out to be easier than just about anything else. Okay. We use the form y equals a times x minus h squared plus k. Vertex is a 2, 4, so h is 2 and k is 4. Now, you do have to understand that this is a transformation of the x squared function to understand that hk is going to be your vertex, okay? Just like your x squared function where you move the red dot to hk. That's what the function would tell you. That's a f of x minus h plus k. So knowing the vertex, then you know hk. And h is 2, k is 4. Graph passes through 8, 9, so we can let x equal 8 and y equal 9. Now using h equals 2, k equals 4, x equals 8, y equals 9, we write out this equation. Oh, there it is. And what's left is a. And that's a really equation to solve. Really easy equation to solve for a. So we solve it for a, we get 5/6. Our equation is then this. We plug in 5/6 for a. We plug in 2 for h. We plug in 4 for k. And right there's a perfectly good vertex form of the equation of a quadratic function of a parabola. We check to make sure that's right. Well, I did that check. It's on the video. Then we do the same thing. Oh yeah, then we digress a little bit. Okay, we found the general form of this equation. What's the general form? Well, that's like ax squared plus bx plus c. Okay. So we just write out the vertex form. We expand the square. X minus 2 times x minus 2, x squared minus 4x plus 4. It's not x squared minus 4. Okay. Don't square this, square that. We multiply out, expanding the binomial. And then we multiply through. We get these fractions, and they're a little messy. But we get this function. Okay. The y-intercept ought to be then 41 over 9. It turns out to be 5.55. Okay. Does that make sense in terms of the 2 points in a quadratic function with a vertex on the line? Well, at this point. Okay. Well, yeah. You just draw this part of the curve, flattening out at the vertex, and try to draw this one symmetric to it. And it's going to rise a little bit from the vertex, which is at y equals 4. Not much. By the time it hits the y-axis, it's at y equals 4.55. It's pretty neat. Okay. We can find the zeros. And it's not going to have any zeros. Obviously, it doesn't have any zeros, but the quadratic formula confirms that. This number here is negative, and it's a lot bigger than what we get when we square this number. And it's easy to see that. You don't have to put it into a calculator. This is going to be less than 1, and this numerator is going to be bigger than this denominator, so you're stuck. But of course, the vertex is here. And there it is. It's at x equals 2, using this divided by this. That's a negative b over 2a. Okay, we get all that. Now, then we do it for the vertex at 8, 9. That's going to be on the video from the MBE system course. Then we get the exponential function through 2, 4, and 8, 9. We use the form y equals ab to the x for the exponential function. We plug in 2 and 4 for x and y, and we get 4 equals ab squared. Well, you know how that works. You've done that. Okay. We plug in 8, 9 here, and we get 9 equals ab to the 4th. And we solve it by substitution in this case, because elimination doesn't work. You don't have linear equations. And sometimes it might, but you certainly don't expect it to. Okay. So what do? solve the first equation for A, we get, just divide both sides by b squared, we get a plus 4 over b squared. We've done this. Okay, so this should be familiar to you. You might be a little fuzzy on it, but we're trying to bring you into focus. Okay, so you got a equals 4 over b squared, and you plug that in for a here, and you get this equation. And then you just use your rules for exponents. Your 4 over b squared times b to the fourth, just gives you 4b squared, because b squared goes into b to the fourth. Leaving b squared, you get this equation, so b squared is this. And it turns out that b is a nice simple fraction. Okay. So you get plus or minus 3/2. For an exponential function, b here has to be greater than 0. You don't do negative powers to, or negative numbers to arbitrary powers. So you can reject the negative 3/2, and now b equals 3/2. So there's your function. Okay. And then you solve for a. Well, I mean, okay, there's b. There is your first equation where you put in b, and that's where we put the b in here, and it gives us this. Then we solve for a, we get the 16/9. And there's our final function. And note that when we put it into decimal form, we see that the growth rate is 0.5, the growth factor is 1.5. If you don't remember what growth rate and growth factor are, review it. It could be important. What's the doubling time? I go through a lot of stuff to say, to find what the doubling time is. And then at the end, I say, and then you should go through it so you see the manipulations and so forth, and the applications of the rules for exponents. But it comes down to the fact that 1.5 to the doubling time is going to be 2. And if x is the doubling time, then the only thing that's going to double the y value is this thing to double. 16/9 ain't going to double, right? To 1.5 to the x can double. If x is the doubling time, then 1.5 to the doubling time is going to equal 2. And after going through all this stuff, we get to that form. 1.5 to the doubling time equals 3. And we solve. How do you solve that equation? Well, we already solved an equation like that. You change it to logarithmic form, and you get t doubling equals log base 1.5 of 2. And you work that out, and I estimated saying, I think it's maybe about 1.8. Now, it looks like we're talking about this. I'm going to run out of time, and I'll have to end this. I'll continue the video on and go over whatever I was missing. That might be most of it. Okay, there's something else. We're not going to have time to do it before. Must be all have to leave. So, but when you see the video, it'll be there. Okay. So listen, y'all have been good. All right. I appreciate everything you've done, the hard work you put in. Stick with it. Test will be in the testing center. Let me ask you, what's the earliest anybody would be taking the test, so I can be sure to have it in there in time?